Alright, so let's continue to solve word problems. Again, you're watching me go through our little game plan. You're seeing me set up and solve, excuse me, sub and solve. Alright, and obviously the word problems are a little bit more wordier. There's a lot more going on, but if you just break it down into these pieces, I think you'll be okay. So reading number 4, I have a rectangular window. It's 4 feet longer than it is wide. If the area is 96 square feet, find the length and width of the window. Alright, so a couple of ways to define our unknowns here. One way is to just label them, right? Length, how about we call that L, and W, call it width. But since we're talking about something that's a little visual, if you would, right? There's my length and there's my width. So either way, whether you verbally write them down and tell me what your unknowns are, or whether you draw them in a picture, some way you've labeled your unknowns. So that's the label of the unknowns. I've got 2 of them, so that means I need 2 equations. And you'll notice that in this equation, or excuse me, all this verbiage, there's an is statement there, and there's an is statement there, and that's basically gives us the 2 equations. So we're kind of back to, can you translate? Alright, and see what that goes. So a rectangular window is 4 feet longer than it is wide. Alright, so when we read that, that's basically saying that my length of my window is whatever the width is plus 4. My length is 4 feet longer than it is wide. So length is whatever the width is plus 4. And then over here, they're telling me that the area is 96. So in this case, we got to go back to this guy right here being a rectangle, and you're going to have to remember about area. What we know about area for a rectangle is its length times width. So what this means then, if we kind of write this formula over here, my area is 96 and it's equal to the length times the width. So there's one equation here, there's 2 equations there. I have 2 unknowns, so as far as my setup is concerned, I am all finished. Alright, so we're ready to do a sub and a solve. So notice I did some translating, and then I had to remember a pretty handy dandy formula. So to solve this, what we're going to do is make a substitution. So kind of imagine for a moment, if I told you that L was 4, what you'd probably do is come over here and replace that L right there with the number 4. But it's a little more complicated, right? I'm telling you that L is W plus 4. So I'm going to come over here and I'm going to substitute, or I'm going to replace that L with what it's equal to in the other equation. So I'm replacing the L with what I claim it to be equal to over here. And there's your substitution. So we just saw a sub. And you'll notice we're ready to solve because I have 1 equation and 1 unknown. And if we distribute over here, lo and behold, we have a quadratic. Right? So how do we solve a quadratic? Well, right now we're going to factor them and make use of the zero factor property. So subtracting 96 from both sides, we get 0 equals W squared plus 4W minus 96. Right? So we're trying to find a couple of numbers that multiply up to negative 96 but add up to 4. Right, so we're really diving deep into our multiplication tables, and I believe that's 12 and 8. Right, so 12 times 8, there's your 6, carry the 1, 96. So positive 12, negative 8 gives us positive 4. So we've got it. So W plus 12 is equal to 0, or W minus 8 is equal to 0. This gives you W equals negative 12. And this gives you W equals 8. Alright, and here's where we got to kind of take into account, there's 2 answers, but we're talking about a physical shape. So having a length that's negative 12 doesn't make any real world sense. I either got some length or I don't. Alright, so our answer here right now is that the width is 8. But we're not done, right? Not only did I have to find the width, but I also had to find the length. So let's come back up here. Right, now that we know what the width is, I'm going to replace that with what I found, and we find that L is 12. Alright, and one last thing here. Unlike some of the previous word problems where they just were some integers and numbers, this has some meaning, right? Because everything is measured in feet, right? Square feet. So that means our length is in feet and our width is in feet. So the final answer for this particular word problem is the width is 8 feet, the length is 12 feet. You'll notice that this is 4 more than the width, and if I multiply them together I get 96, so everything checks out. We're ready to go on and do the next word problem. So in the next one, it's pretty similar, right? We're dealing with a triangle though this time, right? And it has a height that is 6 times larger than its base. And if the area of this triangle is 75 square feet, find the height and base of this garden. All right, so again, we've got some triangular shape, right? They told us that the height, right? We got some height, and we've got some base to it. How about we just call that B, all right? Or capital B if you would. So I've labeled my unknowns there, or if you want to, tell yourself H is the height of this, and B is the base. So we have 2 unknowns, which means I got to find 2 equations. And again, translation-wise, the word is pops up twice. So the first one said that the height, we've called that H, is equals 6 times larger than its base. So that's going to give us the height is 6 times B. Perfect. And then the next says that the area of this triangle is 75. So we're going to have to go back and remember, just like up here, there's a formula for area for a rectangle. There's also a formula for area for a triangle. We know that area is 1/2 the base times the height. All right, and in this case, our area is 75. So 75 is 1/2 the base times the height. So we had 2 unknowns, and through some translations and remembering some formulas, I now have 2 equations, and so we're done with our setup phase. We're ready to do the sub and then the solve. So in this case, again, notice that over here we are told what H is equal to. So I'm going to use that, come over here, and I'm going to replace that H, sub it, all right, with what we know it to be equal. So we have 75 equals 1/2 B and 6B. So if we kind of clean this up over here, you'll notice the 2 goes into the 6 3 times. So we have 75 basically equals 3b squared. All right? And so it is a quadratic, right? And so we usually solve those by factoring, right? And then using the ZFP. So subtracting 75 from both sides, we get 0 equals 3b squared minus 75. GCF, we got the 3, we'll pull that out. And we're left with the difference of squares. So 0 equals 3, b minus 5, oops, and b plus 5. Now that 3 is never 0, so that's not going to worry, but b minus 5 could be 0, or b plus 5 could be 0. And this gives us b equals 5, and then this b gives us negative 5. Again, since we're talking about a physical shape, it doesn't make sense to have a negative number as our answer. So this one doesn't make any sense for the word problem, even though it's an answer to this problem. So the one that makes sense is B is 5. But we're not done, right? Not only did I have to find the base, but I had to find the height. So making another sub, 6 times that height, 6 times that base gives me the height. So in this case, the height is equal to 30. And so again, since we're dealing in times, let's see, 6 times larger, we're talking square footage here. So that means everything is in feet. So this triangle is 30 feet high, and it's 5 feet at its base. Kind of a skinny one, I guess. All right, but the numbers worked out. So a little bit harder, a little bit more wordier, but hopefully you got to really see that setup, sub, and solve. So earn some easy points by declaring your variables. Earn some points by translating and coming up with the same number of equations and unknowns. Make a substitution. Solve what's left using the skills that we've learned throughout Chapter 5. All right, and so we got one more round of word problems coming up, and I will see you guys in the next video.